Hello everyone, welcome to the course Discrete Mathematics. Okay, so when I went to Tokyo University to study computer science 30 years ago, this was my favorite course, Discrete Mathematics. But I'm wondering why I study so many math courses. For example, linear algebra, probability, or discrete mathematics. That's not what I expected to learn in computer science department. What I want to learn is maybe computer games, how to design the games, and how I play games well. Okay, so I was so confused at that time because so many mathematics courses in computer science department. So let's see why we need to learn discrete mathematics. Okay, so maybe you can think of one system you want to develop. Maybe the smart system. Maybe the system can help us doing things faster. But what's behind this system? How to make it smart or intelligent? How? Have you developed your own systems before? No, not yet. So how to make the system smart? Okay, use different algorithms to help it make decisions, for example. Okay, so actually, if you want to develop different algorithms, actually, we are using a lot of different mathematics behind. Okay, so you can consider that's the key or the keystone behind the intelligent systems. So when you want to study AI, because it's a very hot topic, you will see actually we have a lot of different maths behind AI systems. Okay, that's one thing you need to learn is Greek mathematics. And also, it's the bridge or connection to other advanced courses you will see before. For example, programming, data structure, algorithm, graph theory, or image processing, and more. For example, you will see sorting algorithms. I believe you have learned in programming, but we will go further to analyze the complexity of such algorithms. So we will see how we analyze the complexity of a given algorithm. So we have the basic concept introduced in this course. Discrete mathematics will help you bridge or connect to advanced courses such as the algorithm. Okay, you will also see other methods, for example, shortest paths, and then you will see that algorithm again in data structure. So you will feel, wow, it's so simple because I have learned it in discrete mathematics before. Okay, so it's a very key course that help you to learn the advanced course. Okay, so I hope I can give you a little bit motivations of why we need to learn discrete mathematics because we have very diverse topics in this course. Okay, and then we talk about the maths of why we learn discrete mathematics, why we not learn continuous mathematics. Okay, so what is continuous mathematics? You can think of the function you have learned, for example, x squared plus 2x plus 1, you will see it's a continuous function. And we have learned how to we apply calculus to calculate the maximum or minimum of this function. Okay, so we are talking about continuous functions. But in this course, we learn discrete mathematics. Actually, we only consider x equals 1, x equals 2, x equals 3 as this discrete point. Okay, so that's because the reason is when we start computer science, actually we are dealing with different objects. Okay, they are discrete along this range or space of mass. For example, integer, sequence, graph, or logic. So they are not continuous values. Okay, so we are uh, studying the mass, how to deal with the discrete values. Okay, so that's the range of discrete mathematics. Okay, and then you will see more examples when you study the images. You will see a lot of pixels within one image. So we are dealing with 1 pixel, 2 pixels, 3 pixels. Okay, and maybe the videos we have a sequence of frames. So we are dealing with the first frame, the second frames. Okay, so you will see all of those units is discrete subjects. Okay, so we are learning discrete mathematics. Okay, so just like I said, the topic in this course is very diverse. So we will not go through all topics in your textbook. And if you have in your textbook now, okay, so we will introduce the foundations, logic and proofs, and then the basic structures, set, functions, and sequence, and then a little bit about algorithms, and then induction and recursion. Okay, in this unit, we'll combine mathematical induction with data structure, especially recursively defined set, recursively defined functions, and how it will be combined with the proof method, mathematical induction. Okay, and then a little bit about counting. So we'll introduce a very interesting theory, the Pinget-Hall principle. And then advanced counting about how we can solve different applications of recurrent relations. And then actually, it's the time for the entrance examination of master's degree now. So they have just finished their exam right now. And actually, in this year, I provide the problem of advanced accounting a lot in this year. Okay, and the last topic is about graph and trees. Okay, so you can see trees is a special topic about graphs. So we'll see basic concept of graphs and then how these relations can be enhanced to trees. Right, in this semesters, we have the scores for class participation and the quiz and homework assignment, midterm and final examination. This is the textbook we will use this semester. Discrete mathematics applications written by Moses. So actually we have a lot of different versions of this textbook. You can just provide what you can buy in the school bookstore. Okay. And then it's English code class. So I know it's difficult to learn mathematics in English. So you have the chance to raise your hands to understand. We can repeat by Chinese once. Okay, maybe we can see more examples if you don't know. But the key point is you need to let me know you don't understand. Otherwise, we will go to next topics quickly. Okay, so far so good. Any questions so far? Okay, this is the office hour. 1 hour after class every Tuesday and Thursday. And you can make an appointment with me if you cannot attend the office hour at this time. Right, so let's see. This is the maybe the previous students. He posted what he learned in his first year and second year. That's the student from our department. So let's see what he's thinking about this course, this Greek mathematics. Okay, he think this course taught a lot different knowledges. It's sometimes very boring, and the homework is so many. Okay, so that's maybe the disparity of this course. He think, but actually he found out when he programming, he used a lot of knowledge from discrete mathematics. But in this course, he didn't study well. So he need to study by himself again and again. Because when you solve different problems or a programming context, you will see it's very useful to apply the concept from discrete mathematics. Okay, so just a warning for everyone. You need to learn it well. Otherwise, you will see. After that, if you didn't learn well, you still need to use it for other courses, and you need to learn it again by yourself. Okay, so this is a very good chance. You can learn in this class, and we can study together, and then improve your knowledge and help you to study other advanced courses. Okay, so that's a brief introduction of this course. Any questions so far? What percentage you can understand our English? Have you been to other English class before? Yes. What's the percentage you can understand in the previous course?
Let's go to 80 to 90.
80 to 90. Okay, good. Okay, today I will introduce a little bit of our first chapter. It's about the logic and proofs. So we will see the first topic, propositional logic. Okay, so this is an example. When you drink the juice or milk, you may find some interesting sentence. Let's see what is the sentence. For people who like to smile, then he usually has good luck. Okay, he usually not bad luck. But because if he is bad luck, he cannot smile. Okay, how do you think about this sentence? Do you think the logic about these two sentences is correct? If people who like to smile, then he is not bad luck. Because if he is bad luck, then he cannot smile. How do you think about this sentence? Do you think it's logically correct?
I think at some point it can be true.
The change?
I think at some point it can be true.
Oh, okay. At some point it can be true. Okay. Okay, let's see next example. Okay. So for Superman, okay, Superman is willing and he can prevent evil, and he will do it. If the Superman cannot prevent evil, then he's not capable of doing that. If he's not willing to prevent evil, then he's a very mean person. Okay, and we know the truth. Superman does not prevent evil because evil things happen every day. So if Superman exists, then if he is not capable of doing anything, and he's not a big person, therefore Superman does not exist. Okay, so you can see this example is more complicated than the previous one. If you can distinguish, previous one is probably correct. How do you think of this one? if Superman can prevent evil and willing to prevent evil, and he will do it. If he cannot prevent evil, then he is impotent. He cannot do anything. If he's not willing to prevent evil, then he's very mean. He's not a very kind person. And we know Superman does not prevent evil. If Superman exists, then we know the image of Superman, right? The Superman can do anything, and Superman is a very kind person. Based on these previous premises or descriptions, then we can get to the conclusion Superman does not exist. What's your opinion? What's your intuition about this sentence? You think what we had so far and we derive the conclusion Superman does not exist. All of these are correct. Okay, we will see. In chapter 1.5. Okay, we will see how we can transform this sentence into symbols, and then we can derive propositions to describe this sentence, and then we can derive the rules of inference, how we can prove by the given premises, and we can derive the conclusion is true or false. Okay, so let's see the chapter summary. In this chapter, we will see the first one is first kind of logic. We call that propositional logic. Okay, so we'll learn how to propose different propositions and what's the applications and how we consider logical equivalence of different propositions. And then the second kind of logic is practical logic. Maybe you have learned that before because I will introduce the notation for all, for some. Okay, and then we will see logical equivalence about practical logic and nested functions. The next part is about proofs. We will use rules of inference to see how we can prove the logic is true or false. And then we will learn different strategies or techniques, how we prove for some problems. Okay, so this is a summary of propositional logic. We will see the language of propositions. Actually, we are using different connectors, truth variables, and truth tables to help us to develop the system of propositions. And then we will see applications, how to translate English sentence to propositions. And then we can give different system expectations. Okay, once you want to develop a new system, then we have the step. Okay, so what this system looks like. And we need to develop a consistent system spec. If the system spec is not consistent, then the system cannot work well. Okay, and then we'll see different logic concepts and logic circuits. The last part is logic equivalence. We will see important equivalence and showing if two positions are logically equivalent. And then we will see different applications about satisfiability. Okay, we will see the example of pseudo. Okay. So next, we will jump to section 1.1. It's about propositional logic. So maybe we will just introduce a little bit today, okay? And then we can dismiss. Maybe you can use this opportunity to see if you can understand the simplest, very simple section 1.1 by English. If you cannot understand, then I hope you can go to the other class. Because we don't have enough seat right now. Okay, so try it by yourself. If you don't understand, let's go to Chinese class. Okay, let's see definition of propositions. It's a declarative sentence that is either true or false. Okay, so you can consider one sentence is a description about something that is either true or false. For example, the moon is made of green cheese. Okay, we can see definitely this sentence is false because the moon is not made of green cheese. If you can give the truth value, true or false, to this sentence, then it's a proposition. Okay, so let's see the other example. Toronto is the capital of Canada. Is that true? What is the capital of Canada? Ontario. Okay, so if you don't know, that's okay, because Toronto is either the capital city of Canada or not. Okay, so we can eventually give true or false for this sentence. That makes this sentence a proposition. Okay, how about x plus 1 equals 2? Is this true or false? We don't know because x is a variable, right? So when we don't know what is x, we cannot distinguish if x plus 1 equals 2 or not. Okay, so this is not a proposition. How about sit down? Okay, I ask you to sit down. So this is a request, right? So there's no truth or false belongs to this sentence. Sit down. And what time is it? No true or false about this sentence. It's a question. Okay, so it's not a proposition. So let's go back to the definition of proposition. It's a declarative sentence. Okay, you need to describe something about the property, about something. Okay, that is either true or false, then it will be a proposition. Okay, could you give me an example of proposition? Professor John is so handsome. Right? True or false? Okay. The answer is not important because once you can answer true or false, then it's a proposition. How about your answer? Give me one example of proposition. Is that too difficult? Anything. Declarative sentence. Okay, let's talk about following. Give me one example of proposition. Please repeat the definition of proposition in Chinese. What's the definition of proposition in Chinese? OK， 好，有一个陈述，它是可以知道它是真的或假的。OK，so could you give me any? You can say Chinese, that's okay. You can differentiate is true or false. Okay, good. Because you can see that will be true or false. Okay. That will be a precision, no problem. Okay, next let's see propositional logic. When we construct the propositions, we need two different propositional variables. Okay, so we can replace the sentence into different propositional variables. For example, P, Q, R, S. Okay, And then what is compound propositions? Because maybe the sentence is too complicated. We have too many subjects. Then we can replace them by different verbs. And then connect all these verbs together using conjunction, disjunction, negation, implication by conditional. Okay, so maybe conjunction and disjunction you can consider as and or. Okay, so for example, P and Q or R or S. Okay, so next let's see the truth table of negation. Negation means we make it inactive. Okay, so if we have a proposition and we use the variable P to indicate the proposition as P, okay, and we can use not P to indicate it's the negation of the original proposition. Okay, so the truth table is very easy. In the proposition of P, the moon is made of green cheese. So we just replace this sentence to the variable P, and then we can see if it is proposition, then it can assign true or false values to the proposition. So the negation will be the other side. Okay, if P is true, then the negation of P is false. If P is false, then the negation of P is true. Okay, so this is the truth table using the connections or collective negation. Okay, let's see the example. If P denotes the Earth is round, then the negation will be it's not the case the Earth is round. Okay, that means the Earth is not round, or maybe it's rectangle or other shape. Okay, next one is conjunction. The conjunction of propositions, usually we have two propositions, P and Q, so we can use the notation. Okay, actually we can call it P and Q. And let's see the truth table. If P is true and Q is true, then P and Q is true. Otherwise, if one of them is false, then P and Q is false for the other three cases. Okay, so you can see N is a very strong conditions because we need both P and Q is true, and then the results will be true. So let's see the example. If P denotes I'm at home and Q denotes it's raining, then P and Q means I am at home and it's raining now. Okay, both positions should be true. Conjunction it also means or. Okay, so we can see the truth table. Once P and Q, one of them is true, then P or Q is true. Only if P and Q are both false, then the result of P or Q is false. Okay, so it's a very easy interpretation of conjunction and disjunction if you can consider it as and or. Okay, next we have two types of or. One is inclusive or and exclusive or. Okay, so let's see the first type. Students who have taken CS2 or 2 or Math 1 or 0 may take this class. Okay, so it sounds like a prerequisite. You need to take CS2 2 first, and you also need to, or you need to take Math 1 to 0 first, and then you can take this Greek mathematics. Okay, so it's kind of or, right? So what happens if one student takes just CS202? Can he take this course? Yes, right? What happens for this student? He takes CS202 and Math 120. at the same time, he take this course before. Can he take this class? Yes. Okay. So we call this inclusive. He can take either one of these 202 or S120, then he can take this course. So maybe we can compare to exclusive or. Okay. If you read the menu, you go to the restaurant and see soup or salad come with this entry. Okay, that means you can choose either soup or salad. You cannot choose both. Okay, so we call this exclusive or. Okay, you might see this a lot, right? For example, you can see the menu, they provide 5 different dishes. You can choose 3 out of these 5. Okay, so in this case, only soup or salad. Actually, you can say no, I don't want them all, and the waiter will say yes, it's your own choice. But you cannot choose soup and salad at the same time. Okay, so we call this exclusive order. Do you have other examples of exclusive order in our daily life? One extra point if you can provide such example in Chinese. Okay.
选修2门通常的课，就是同一个时间的课。
好，假设你选修了2门冲常的课，到时候就只能选1门而已。Okay. So that will be exclusive order. Okay, very good. You can go to TA and advance. Maybe do you want to introduce yourself a little bit? You're not TA.
应该是。
Okay. So maybe stand up and let students know you better. So what's your name? Could you introduce yourself a little bit? Okay, so let's go to TA for the extra points. Okay, next let's see implication. Okay, so if P and Q are positions, then we write if P then Q is a conditional statement, or in implication, we read if P then Q. That means P is the hypothesis or premise, and Q is the conclusion or consequence. Okay, then we have the truth table like this. If P is true and Q is true, then if P then Q is true. Okay. Next, if P is true and Q is false, okay, that means if P then Q, this statement is not correct. Okay, so we have false. Okay, next, if P is false, no matter Q is true or false, then the statement will be true. Okay, so it sounds a little bit weird. Why if P is false and Q is true or false, then the result remains true? Okay, so maybe we can go to one example to see why the truth table of implication, just like this. Okay, so we may see many people for elections, so they make promises. If I'm elected, then I will lower taxes. Okay, maybe on the president lie. Okay, he says, if I'm elected, then I will lower the taxes. So what do you expect for the candidate? If he's really elected and the tax is lower, then you will be satisfied, right? But what happens if he's not elected? What's your opinion for the tax? If it goes higher or lower? it doesn't matter, right? Because it's not elected, it's not the president. Okay, so if the premises is not true, then we don't care the consequence of Q, and that makes the implication is true. Okay, because it doesn't matter. Maybe you can connect this example to help you to remember the truth table. Why we have false for P and Q either true or false, and the result remains true. Okay, so let's see more about the implications. If P then Q, there does not need to be any connections between the hypothesis and conclusions, because we only consider the logic of these propositions. Okay, so the meaning of if P then Q depends only on the truth values of P and Q. Okay, so it doesn't have to literally correct. For example, if the moon is made of green cheese, then I will have more money than Bill Gates. You can see, but literally, this meaning is insane. But it doesn't matter because we only consider the truth value of P and Q. For example, the moon is made of cheese. It's false. I have more money than Bill Gates is false. Okay, so if we have false and false for P and Q, then we have if P then Q true in this case. Okay, do you understand what I mean? Okay. Alright, and for your homework assignment, you will see a lot of different ways to express P then Q. So you will see the sentence if P then Q, or in short, you can see if P, Q, okay? Otherwise, you will see Q if P, okay? It's the same thing, right? Q whenever P, Q follows from P, all right? And then P implies Q, because we know the kind of proposition is implication. That means if P then Q means P implies Q. P only if Q. Q when P. Okay, when P happens, then we will have Q. And P is sufficient condition for Q. Q is necessary condition for P. Okay, so you will see all these different ways to express if P then Q in your homework assignment. I hope when you see this different sentence, you will see actually its implication. Right, I think it's enough for today. Any question for the section 1.1? Okay, I want to invite someone to give all of this in Chinese, just a quick summary for everyone in Chinese. What do we have learned today? One extra point. Anyone? A quick summary of section 1.1 I've taught today.好的，你们期末被当掉的时候，就会发现这一分非常的珍贵啊！好，除了这位同学之外，有没有其他同学？因为他刚才加过一分哦。那让一个机会给其他同学好不好？
就是今天前面有教，如果在变数有 T R Q R S 然后如果前面有一杠往下撇的话，是指它相反的意思。如果它是原本是 true 会变成 false。然后 or 的部分有分成那个 inclusive or 跟那个然后跟 inclusive or， 然后一个是两A 跟 B 同 A 跟 B 只要有一个成立，它就会是 true。然后另外一个是只有其中一个成立的时候才会成立。然后还有and 的前提是两个都是 A 跟 B 都是 true 的时候，它才会是 true，然后这样都是 false。
OK， 好，所以这个同学解释了详细我们刚刚学的 truth table 嘛，好，有没有什么家长有问题啊？有没有同学可以给一个更全面的总结？我们刚刚上课上了哪些东西？再送一分吗？不要吗？要不试试看，随便讲嘛。你看他随便讲就得1分了，有没有？有吗？好，简单讲吧，好，那给你机会哈。好，怎么样的表示方法？还有吗？对，总结。好，我帮大家总结一下好了。好，第一个呢就是什么叫做conversation嘛？好，首先要知道conversation的定义。好，那知道conversation之后呢，conversation可以转成符号表示，就会有 PQRS。那有 PQRS 之后呢，就会有它的连接符号 and or not。那 and or not 这些什么意思呢？好，就是从这个 truth table 去了解它的意思是什么。好，那这应该就是我们今天讲的这些东西。好，那没有问题的话，我们就到这边结束。好，下礼拜再见。我们可能没办法加签了耶。啊？对，已经没办法加签了。好，教室都坐满了，这样。我们还有另外一班可以选，这样。好，教室已经坐不下了，不好意思。好。哎，你说2个了。我以为没有，他没有。哦，还是只说真的，我就是那个以后你是用那个，接下来我们真的假的？因为那个哦，那我就说真的假的？他敢死我！对啊，已经很买了，我不知道。对啊，因为我觉得也是，我有点好奇，那有这么必修吗？也太多了吧！非常简单。
可是很夸张哎，这多人。